Hello everybody, welcome to AP Physics today. These are notes on Newton's law. I'm just going to show a bunch of examples and explain things. So we're going to have a crate on frictionless surface, and the weight of it is 785 newtons, and you pull it with a force of 135 newtons at an angle of 35 degrees from the horizontal. The question is, what's the acceleration and the displacement of it after 2 seconds? We'll say that this has an initial velocity of 0. Okay, so the reason why I showed this is because it's a vector question, right? So if I take this as the x, this is the x portion of the force that's going to accelerate this thing, right? So, and then this would be the y. This has nothing to do with anything at this point, but it will later when we study friction. But for now, we have to figure out, because this is going to be the force that's in the x direction, which is going to be what causes this thing to move. So the force in the x direction then is equal to cosine 35 times 135, which is 110.59 newtons. So that's the amount of the tension force that's going to accelerate this object in the x direction. So we can say then the force in the x direction is going to cause this mass to accelerate. So the acceleration is the force in the x divided by the mass, which is 110.59 divided by 78.5 kilograms. Acceleration in this case then is, so then the acceleration ends up becoming 1.41 meters per second squared, and your displacement then is equal to 1/2 AT squared, right? So you 1.41 divided by 2 times 4 becomes 2.82, maybe, if I did that right. Can I get a confirmation? Okay, so there's just a kind of little warm-up for you. Now on to what we are going to talk in more detail about today. Okay, so now we're just going to talk about tension on a rope. The first one is this, okay? So we've got a 10 kilogram mass. My question is, what is the tension? Okay, well, the force of gravity on this object here is 100 newtons. So the tension must be 100 newtons as well, otherwise the thing would be moving. And it's not, okay? So now my question is, I've got a 10 kilogram mass, and I've got a 5 kilogram mass. And my question is, what are the two tensions? Okay, so tension 1, well, this thing weighs 50 newtons, so or this is tension 2, that better be 50 newtons, otherwise it's going to be falling, right? This thing weighs 100 newtons, so this tension is going to have to hold both weights, so that's 150 newtons. Any questions about that? Okay, for this now we have 2 ropes, so I want you to figure out both the tensions in these ropes. Okay, so how do you do this? Well, you have to split this up into vectors. So we know that we have a force in the x direction here, and we have a force in the x direction there. So we might call this Tx1, Tx2, because we call this T2 and T1, right? And then we have T in the y direction, 2, and then a T in the y direction, 1, okay? So really what you need to do is come up with some formulas that kind of describe this. Okay, so this is important for everybody to listen to. We can say that Tx1 plus Tx2 equals 0. That's our summation of forces in the x direction. Do you agree? Now, how does that happen that we have them looking like they're in the same direction? Well, if you actually put in the number for Tx1, you would see that if we call Tx1 positive, then we would have to call Tx2 in the negative direction. And so they're the same value, they're opposite in direction. So here's where it gets kind of confusing. Tx1 then equals Tx2. And algebraically, when you solve and put these both on the same size, or on the same side, you can see that Tx1 minus Tx2 equals 0. So that is, where all this is always coming from. I don't always show these steps. But this is something that you actually have to understand. Do you have any questions? Okay, so if we want to look at how we, solve these, and there's going to be a bunch of different ways to solve these questions every time. So I'm just going to write down a couple formulas here that I know. So I'm going to say Tx1 equals Tx2. So that's a formula, right? I'm going to say Ty1 plus Ty2 equals, now here's the question, what does it equal? Well, these are the only pieces that are going opposite of gravity. So in this case, they equal the force of gravity. So it's 100 newtons, which happens to be the force of gravity of that ball. Okay? So now, these are our two kind of big formulas. Okay, so now what you're going to want to do is kind of get numbers in for this. Okay, so if you look at Ty1 up here, Ty1, how do you? Well, here's theta here, right? So could you say that Ty1 is sine of 30 T1? Could you say that? Yeah. So then that's what you're going to want to put in. Substitute. So sine 30 T1 plus sine 30 T2 equals 100 newtons. Okay, so we've taken our formula and we've made it a little bit more workable, right? But we still have two variables. So now what do? Well, you go up to this, Tx1 plus Tx2, and you can maybe put that into a more workable situation. We could say, if you look here, Tx1 is what? Cosine 30 T1. Do you agree? And this is going to be cosine 30 T2. So now we can write a formula for that. Cosine 30 T1 equals, this time, cosine 30 T2, right? And they're in the opposite direction, but the summation of forces is 0, which makes them both positive when they're set on the opposite side of the equation. So now you can solve for either T1 or T2 and plug it into the other formula. So I would say T1 then is equal to cosine 30 divided by cosine 30 T2. Okay, so you can see that you don't need to use a calculator for this one, right? T1 then equals T2. Okay, so now we can just look at our equation that we started with up here, and we can solve real easily because we know T1 is equal to T2, so we can put either or in. So I'm just going to put T1 here, right? So 2 sine 30s T1, or I'm sorry, T2s, or whatever, yeah, T1 equals 100. So then T1 then solved for becomes 100, right? I believe so. I don't know. It seems too simple. So then you look up here, and where did we come up? Oh yeah, I erased the formula that said that T1 equals T2. But now if one's 100, the other one's 100, so your answer to this is 100 newtons. 100 newtons. Okay. Any questions on that? Okay, so here's our next problem. We got T1 and T2 at different angles this time. So the first thing you have to recognize is this is not a weight, so I'm going to put that in right now, 200 newtons, because that's what we use when we're dealing with forces. You got to realize here too that this is T2 cosine 60. Do you agree? Usually written the other way. Now, also you have to realize this, that this right here is equal to, because there's no movement in the x direction. So these two have to be the same size. So this one is T1 cosine 20, okay? And then if you look at what happens, is so you always draw your x's first because you know they're equal. And then you look and see, well, this piece right here then is going to be more. So right now you can see which, that T2 is going to be bigger, right? And so if you're just looking at the picture, the shorter one is almost always the bigger one if they're hanging off the wall like that. So then this is the sine of 60 T2. So what I do is I just go and label all my pieces right away. This is the sine of 20 T1. And then I start with my formulas now. So I say, okay, so I got this piece here is going upwards. This piece is going upwards. Those are the only two that are going upwards. They're the only thing that can take care of the force of gravity. So I could just say right away, 200 newtons is equal to sine 20 T1 plus sine 60 T, make some room, 60 T2. Okay, so, you know, for me, I guess it's easier to put this into decimal form at this point and then solve for either T1 or T2. So let's go ahead and do that. And so I simplified the sine functions to their decimal form. And then just to solve for, you know, I guess T1 or T2, it doesn't really matter. But I guess I'll solve for T1 then is going to be equal to 200 minus 0.866 T2 all over 0.342 T1. And actually at this point, I even put these into decimal. So I actually do the math here myself. You can do whatever you want. Yeah, I don't know why I put T1 over here. I was trying to solve for T1 and I didn't. So it's 200 minus 0.866 T2 all over 0.342. So then T1 becomes equal to, what's 200 divided by 0.342? So then we come up with this final equation here for T1 in terms of T2. Just kind of set that off to the side and don't forget that. And now we have to work with our x's. So I'm going to erase all this here, keep the rest of it. So now our x situation then is going to be equal to each other. So this one should be a little bit easier, right? So we got T1 cosine 20 equals T2 cosine 60. Okay, so T1 then is going to equal cosine 60 divided by cosine 20 T2. Okay, so T1 then equals what? 0.532 T2. Okay, so now we have our second equation here. So now we just start putting them together. And you guys have done substitution before quite a bit, I'm sure, right? So that's all it is. So you could just set these two equal to each other, the way we have it written. So 0.532 T2 equals 584.8 minus 2.53 T2. You know, get those all over on the same side. You know, 3.662 T2 equals 584.8. Divide both sides by 3.662. T2 then equals, Okay, we had a little problem here with adding, which doesn't surprise me. So our final answer then for T2, because the actual answer should be 3.062 T2, so we divide it by 3.0. Our T2 then is 190.986 newtons. Do we agree with that? Okay, so now we still have to get T1, right? So do we, oh look, we can use this formula right here to solve for T1, correct? So let's do that. So T1 then equals 584.8 minus 2.53 times 190.986. And our number for T1 then is 101.605. Do we agree with that, people? Okay, and that's how you solve tension problems. Hopefully this helps.